I want you guys to all first picture yourselves walking into a salon. Here, instead of choosing a new hairstyle, you're choosing new jeans. Would you buy an enhanced memory jean pack that has a coupon for IB students? Perhaps a perfect athleticism combo. The case where we can edit our genes easily is a future that we are quickly approaching. And with these emergent technologies, we are facing questions that no challenges before have ever had to answer. Today, I'm not here to assert whether genetic editing is right or wrong. Instead, I want to explore how we can face this revolutionary gene editing technology together, making more informed bioethical choices about our genetic life. So what made this genetic salon possible is actually a gene editing technology named CRISPR. So it has the power to alter the very blueprint of our lives, our DNA. In 2012, scientists find out a way to hijack CRISPR so that it can not only target viral DNA, but any DNA in almost any organism. The CRISPR-associated protein's molecular scissors would snip through the targeted sequence of DNA, and just like that, your gene would be edited. So, with the advent of such technology, there are many warnings to be noticed of. This technology has immense potential as a precision gene editing tool, which can alter your genes as easily or as hard as fixing your hair. Scientists can now alter your genes, eliminate these genetic diseases, traits, or even redefine what it means to be human. So it seems that this enhanced version of gene editing is all great, right? But in reality, the most controversial aspect of this technology is due to its inherent capacity to change any aspect of the human body. If not used properly, it can result in a toxic relationship between social engineering and genetics, which triggers problems in two main parts: informed consent and inequality. So once this gene editing technology progresses to the market or clinic, the first main problem would have emerged. Will individual consent be considered seriously? Let me demonstrate this with an example. Imagine you're expecting a baby, and your doctor offers you a menu full of genetic choices. You can not only prevent diseases like ADHD or sickle cell disease, but also potentially enhance your child's features or abilities. But here's the trick. Your unborn baby can't tell you what they want. Think about it. We already debate heavily on parents making choices for their children, from vaccination to education. So if we apply the same logic here, then the unborn baby would have their own body autonomy and rights, and thus it would be unethical to alter its genes without its consent. So now, with the emergence of these new gene editing technologies, this takes it to a whole new level, because it's like choosing someone's permanent identity without their input. While some say that my parents make choices for me all the time, but others say that permanently altering someone's genetic code crosses a line. So now a biologist may come in and offer us a solution. We can make a distinction between technologies that are enhancive and those that are therapeutic. Let me explain this a little further. No babies wish to grow up to develop life-damaging diseases like hemophilia or Huntington's disease. So when a mother decides to edit these genes out, then we can agree that she can be granted without explicit consent from the baby, right? But when it comes to enhancement purposes, like making the baby sprint faster or do math better, then that would not be applicable, thus solving the problem of consent. However, this single scientific perspective is not enough to solve the problem. All our previous discussions regarding consent assume that everyone in society can get a share of this technology, when in reality, that's not possible. When this technology progresses to the market or clinic, it would undoubtedly be expensive due to its transformative potential. The poorer part of the population cannot get the chance to even make a consent. And that is due to socioeconomic disparities, which leads us to our second main problem of equity. So this problem actually concerns the majority of the population who do not have the financial capability to acquire these resources. Let's take brain-computer interfaces as an example. So BCI, generally, they use arrays of electrodes to read brain signals to computing machines and uses that computer's power to increase your intelligence. So like genetic editing, BCI is also a double-edged sword. It can be used therapeutically, like to transmit the inner speech activity to an external speaker device, which can help those who struggle with speaking illnesses, like locked-in syndrome. It can also demonstrate dramatic impact on those who are in vegetative states. For enhancement purposes, you can use these linked computers to revolutionarily increase your intelligence. However, unlike gene editing, for BCI, this price of this technology is so high that there would hardly be any therapeutic use available. Once that top 1% of that rich population gets a hold of that resource and becomes godlike by increasing their intelligence using these powers like BCI, this would only increase social stratification and make the resource distribution more fixed. These individuals, of course, who can acquire these resources from leading firms like Neuralink by Elon Musk, offer new potential. But in short, the monopoly of technology adds to socioeconomic inequalities through biological enhancement, making this technological problem require a philosophical or sociological solution. So you may wonder, how do we even move forward with such powerful technology in our hands in a both fair and responsible way? Well, I would approach this problem by proposing a two-part system. One, innovation. Let the scientists innovate freely and explore in their labs. After all, we don't want to stifle with breakthrough discoveries. Second, oversight. When the technology is ready to be spread to the market, a review committee made up of professionals from fields of science, business, and economics will discuss the future usage and vote on the future usage of this technology. Enhancement or therapy? So this provides a fair and effective framework without risking dramatic welfare loss due to the slowing of innovation. However, the most important part of the system that actually helps us navigate between the blurred lines of enhancement and therapy and also connects these two parts would be education for both the public and medical professionals. Because educating people about the long-term implications of these technologies is extremely crucial for them to develop more informed decisions. Understanding the why behind technology is what really matters, because education gives us the ability to ask better questions, even if it doesn't give us all the answers. So we've come a long way from discussing problems of technologies like CRISPR and their potential solutions. So has anyone changed their minds about whether or not to edit their genes? It's not just for yourself, but for the whole of society, because this isn't just a scientific breakthrough that needs some technical solution or an ethical dilemma for philosophers to debate about. This is a technology facing all of us. But through education, we gain the language to ask the right questions. Through government oversight and review committees, we create safeguards that can reflect the opinions of society as a whole. And through a fair arbitration process, we can ensure that decisions aren't only left to politicians or scientists, but to ethical principles that reflect us all. These solutions do not guarantee success, but they make it possible for us to make more informed decisions with intention. The future of genetic editing is no longer about whether or not we can do it. It's about how we choose to shape this technology together. And if we engage in this process actively and thoughtfully, I'm confident that we can find a path forward where we can share our values and aspirations. Thank you.